Hello everyone, a very good evening all of you and a very warm welcome to you all to this wonderful session of fluid mechanics where we will be talking about the hydrostatic forces. Please guys do join me fast, and those who are here, please respond me through the comment section if my audio video are clear. Am I properly audible and visible to all of you? So we have already had two sessions for the various topics of fluid statics. One was Pascal's law and its application. The another topic which was taken yesterday was the hydrostatic law. And based on Pascal's and hydrostatic law, we have discussed how to write the pressure equation for the manometer for the static pressure in a fluid, right? So if anybody is having anything to ask regarding those two topics or regarding those two laws, you are most welcome, because that makes the foundation for the hydrostatic force. Hi Pravalika, welcome, good evening everybody. Once again I welcome you all from the bottom of my heart to this wonderful foundation course for GATE 2025 aspirants. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum, Vanakkam. Please get yourself settled down fast. Keep your notebook, pen and calculator so that you can get yourself involved 100% for improving your understanding, for improving your fundamentals for the subject of fluid mechanics. So it is my humble request, every time I keep on requesting the students to share your knowledge, to ask me your doubts, to communicate with me, to make the session more and more lively and communicative through the comment section. So I want everyone to just give me your presence by writing in the comment section. Are we ready to start our session? And please do not forget to like, share and subscribe our YouTube channel, that is Byjus Exam Prep for civil and mechanical engineers, so that the session reaches to all the individuals who are sincerely preparing for the GATE 2025 examination. So this is my schedule for fluid mechanics. After my schedule, there will be the next subject. 4 sessions I have planned for you from the fluid statics. Pascal's law had already been covered day before yesterday. If you have missed it, this is the link. You can watch the recording to have the better understanding of the Pascal law. Then hydrostatic law had been discussed yesterday at 6 p.m. and today we will be going to talk about the hydrostatic forces. What are hydrostatic forces? Every day the timing will be 6 p.m. and tomorrow will be the last session for the fluid mechanics, or I would say fluid statics, that is buoyancy and Archimedes principle. So that will cover the most important topics of fluid statics and will help you to boost up your confidence and will help you to improve your understanding. Your understanding become more better if you practice a lot of numericals on your own. Then only you will become more confident and you will be able to apply the concepts in numerical problems. All right. So for those who are attending my session for the very first time, this is my quick introduction. My name is Chandrasekhar, mechanical engineering graduate from IIT Delhi and also cleared engineering services examination, worked in Steel Authority of India Limited for a couple of years, and from last 11 plus years I have been into teaching, guiding the students who are preparing for various competitive examination, and fluid mechanics, heat transfer, thermal as well as industrial engineering are my favorite subjects. So if you have anything to discuss regarding your preparation, regarding any of the subjects which I have mentioned, you can always connect with me to this mail ID, I will be more than happy to help you out, or it will be always better if you join me on the Telegram. My Telegram channel is Mechanical by Chandrasekhar, and you can use the link to join. More than 1650 students are already part of my Telegram channel and who are preparing for various competitive examination, be it GATE, ESE and other PSUs. So you will be getting benefits if you join a group where all are aspiring to crack the competitive examination, or you can join me by scanning this QR code. All right. So shall we start? This was my quick introduction. Now we are ready to explore the beauty of hydrostatic forces. Shall we start? Every one of you, please do respond. Are we ready to explore? Are you ready with your pen, notebook and calculator? Yes, every time as usual I ask you a basic simple question before I start giving my understanding of the subject. The basic, fundamental, simple question based on the previous discussion is, the question says pressure variation in static fluid with depth is. Pressure variation in static fluid with depth is. What is the nature of variation of pressure with depth? Yes, what will be the nature of variation of pressure with depth? Will it be linear? Pressure as a function of Z. Will it be linear? Will it be exponential, or can be linear or can be exponential? What will be your answer? Everyone. What do you think? The variation of pressure with depth, depth means Z, is linear if density of the fluid is constant, or for the incompressible fluid, the variation of pressure versus depth is linear. The pressure versus depth variation is exponential if density is not constant. Compressible fluid. For liquids, it will be linear, and for gases, it will be exponential. So the correct answer will be option C. It can be linear, it can be exponential based on the density of the fluid, whether the density of the fluid is constant or variable, right? Okay, then let us start talking about the hydrostatic force. What exactly is the hydrostatic force? क्या होता है hydrostatic force? Hydrostatic force is the force exerted by the static fluid pressure. It is the pressure force. It is nothing but the pressure force exerted by static fluid. Hydrostatic force is the pressure force exerted by the static fluid. And pressure force is pressure into area. Isn't it? Pressure into area will be the pressure force. Yes or no? But the problem with pressure force, we can calculate pressure into area, but pressure is varying linearly with depth. Pressure is a function of Z. It is variable. Because pressure is a variable parameter, that is why we need to go for integration. So hydrostatic force, what we will calculate in hydrostatic force? We will calculate the magnitude. In hydrostatic force, we will calculate the magnitude. And then we will also calculate the point of application. What do we call the point of application of hydrostatic force? What is it called? Anybody is having any idea? The point of application of hydrostatic force is known as. So there are two situations of the surface in which we will be calculating the hydrostatic force. The first one will be the plane surface. The surface is a plane surface, let us say like this. If it is a plane surface, can you see it? Plane surface. Let me have something else. The plane surface can be like this. This is the plane surface. This will be the plane surface. So we will calculate the hydrostatic force magnitude on the plane surface. and we will calculate the point of application. Now there will be three orientation of the plane surface we will be talking about. One is when the plane surface is kept in vertical orientation in the static fluid. Then how to calculate the hydrostatic force and point of application. Then the second possibility is if the plane surface is in an inclined position. The third one is if the plane surface is kept in horizontal position. So these are the three orientation of the plane surface we will be talking about. And then we will be talking about the curved surface. If the surface is not a plane, if the surface is a curved like this, if a curved surface is kept in a fluid, if a curved surface like this is kept in a fluid, then we will calculate the magnitude of hydrostatic force as well as the point of application. So let us start talking about the plane surface, and let us talk about the orientation of the plane surface as vertical. This is our vertical plane surface. This is the vertical plane surface. The shape of the plane surface can be rectangular. The shape of the plane surface can be square. It can be triangular. It can be circular. It can be semicircular. It can be anything. The plane surface can be having any shape, but the orientation of the plane surface is vertical, right? This is the free surface of the liquid, and the density of the liquid is, let us say, rho f. Now look, at a depth x from the free surface, if we take an elemental area dA, this is dA and this is at a depth x from the free surface. So what will be the pressure? What is the pressure at the free surface? Gauge pressure will be 0. So if I ask you at a depth x, what will be the pressure? Isn't it rho into g into x? That is what we have discussed at a depth x from free surface. At a depth x from the free surface, pressure is given by rho gx, and force dF will be equal to P into dA, dF, and the direction of this force will be normal and compressive. Yes or no? The direction of force will be normal and compressive. This will be dF. Now if we integrate from m to n, then we will get the total hydrostatic force on a vertical plane surface. So the total hydrostatic force is integration of dF from m to n, from the top to bottom, or we can say that is integration of rho into g into x into dA. Rho is constant, the fluid is incompressible, rho is constant, so that is written as rho into g into integration of x into dA. And what is the integration of x into dA? Integration of x into dA will be area into x bar. So F will be equal to rho into g into A into x bar. Integration of x into dA is equal to A into x bar. This is the integration. So the hydrostatic force is given by rho into g into A into x bar. Or if we say what is this rho g x bar? Rho g x is the pressure multiplied by area. So this is called as average pressure developed on the plane surface, vertical plane surface, into area of the plane surface. This is how we can calculate the amount of hydrostatic force. This is how we can calculate the hydrostatic force. The unit will be Newton if everything will be mentioned in their SI unit. So what you need to remember is F is equal to rho g A x bar, or P average into area, where P average is equal to pressure which is developed at center of gravity of the plane surface. Let me call this to be G. This is G. This is G, center of gravity, and this distance is known as x bar. This is called as x bar. the depth of centroid of the plane surface from the free surface is called as x bar. So average pressure is the pressure which is developed at the centroid of the plane surface, which is rho into g into x bar. That is the average pressure. So average pressure multiplied by, because the pressure was variable, so if we can calculate the average pressure multiplied by the area will give you the total hydrostatic force. Are you getting it? So average pressure into area. So the hydrostatic force F will be either written as average pressure into area, or we can write it as rho into g into a into x bar. This is the formula, where rho F is the fluid density. Very simple, density of the fluid which is constant. The unit will be kg per meter cube, and g is acceleration due to gravity. G is acceleration due to gravity, that is 9.81 meter per second square. A will be the, that is important, A will be the area of plane surface, area of the plane surface in contact with the fluid. In contact with fluid. हाँ सनी गुप्ता, फ्लूइड डायनेमिक्स भी पढ़ाएंगे, बट this session, this series was well planned before, earlier. So that is why this series is planned for the fluid statics. Next time I will talk about the fluid dynamics, क्योंकि dynamics बहुत lengthy topic है. So dynamics में भी ideal flow, real flow, there are internal flow, external flow, बहुत सारे topics है. तो specifically अगर आप मुझे बताएंगे which topic you are most interested into, then definitely I will plan a session for that particular topic. A will be the area of the plane surface in contact with the fluid. The unit is meter square. And x bar is the most important. What is x bar? X bar is the depth of centroid of the plane surface. X bar is the depth of centroid. I have mentioned the centroid as G of plane surface from free surface of the liquid. From the free surface. The measurements are all from the free surface of the liquid. So if you are able to put these values, then you will get the hydrostatic force F. Is this all clear? So average pressure is the pressure which is developed, and average pressure is equal to pressure at G, that is rho into G into x bar, multiplied by the area of the plane surface in contact with the fluid. Now that after calculation of hydrostatic force, we will calculate the, आप मुझे ये बताइए, now you tell me, if I am having a plane surface like this, if I am having a plane surface like this, if I am having a plane surface like this, this is the vertical plane surface. The vertical dimension is 4 meter and the horizontal dimension is 3 meter, 4 by 3. This is how the vertical plane surface is, 4 by 3. If the free surface is coinciding with the top edge, then what will be the area of the plane surface? What will be the value of area? अच्छा सनी, डेफिनेटली बर्नौली इक्वेशन की बात करेंगे नेक्स्ट सेक्शन में. कल का सेशन तो है फ्लूइड स्टैटिक्स का. आई विल प्लान सम सेशन ऑन बर्नौली इक्वेशन डेफिनेटली. सो इफ द फ्री सरफेस, आप मुझे इसका जवाब दीजिए, इफ द फ्री सरफेस ऑफ द लिक्विड इज कोइंसाइडिंग विद द टॉप एज, देन व्हाट विल बी द एरिया ऑफ द प्लेन सरफेस? इजंट इट 4 by 3? 4 by 3. And what will be the value of x bar? X bar is the depth of centroid of the vertical plane surface from the free surface. Isn't it 2? X bar will be 2 and area will be 4 by 3. If the free surface of the liquid is 1 meter above, listen very carefully. If the free surface of the liquid is 1 meter above, if the free surface of the liquid is 1 meter above the top edge of the vertical plane surface, then what will be the area? What will be the area? Area of the plane surface in contact with the fluid. It will still be 4 into 3. No doubt in that, isn't it? Then what will be the value of x bar? People commit mistake in x bar only. What will be the value of x bar? X bar will be the depth of centroid. Centroid will be at the same level, at the same position. Centroid will remain at the same position. The depth of the centroid of the vertical plane surface from the free surface of the liquid will be the value of x bar. So because it is at the same position, but if we measure its position from the free surface of the liquid, it will give you 3, isn't it? Won't it be 3? The value of x bar will become 3, even though we have not changed the surface, even though we have not changed the liquid. The only changes made were the liquid free surface is lying 1 meter above the free surface. Now my question to all of you is, if the free surface is lying 1 meter below the top edge, if the free surface is lying 1 meter below the top edge, then what will be the value of area? If the free surface of the liquid is lying 1 meter below the top edge, then what will be the area in that case? Bataiye quickly. I want everyone to respond. Those who are here, every one of you, do not get afraid of committing mistakes. Even if you are committing mistake, it is all fine. कोई problem नहीं है. But the more you try, the more thinking ability you develop, the more understanding you develop. So if the free surface is lying 1 meter below the top edge of the vertical plane surface, then what will be the area? A will be the area of the plane surface in contact with the fluid. This is not the part of our area because that is outside the fluid. Only this area 3 into 3. सनी, मैंने अपना टेलीग्राम चैनल अभी दिखा देता हूं फिर से, मैकेनिकल बाय चंद्रशेखर. अब कितना होगा? एक एरिया होगा 3 into 3. 3 into 3. Area will be, this will be 3, this will be 3. 3 into 3 will be the area now. And what will be the value of x bar? What will be the value of x bar? Everybody, please do let me know. Sunny, this is my Telegram channel. You can scan this QR code or you can search by the name Mechanical by Chandrasekhar, or you can use the link. So now the x bar will be half of this 3, 1.5. It will be half, it will be the centroid of the area which is in contact with the fluid. It will be the centroid of the area. It will be 1.5. The value of x bar will be 1.5. Do you understand it? I hope this is clear to everyone. अगर किसी को कोई doubt है, if you have anything to ask, please do let me know without any hesitation, without any fear, without any sankoch. Now the next part is about calculation of center of pressure, the location of center of pressure. And what is center of pressure? It is the point of application of total hydrostatic force. Whenever we are drawing the free body diagram for the plane surface, the weight should always be shown at the centroid. The weight of the body is always shown at the center of gravity or the centroid, and the hydrostatic force must be shown at the center of pressure. Now, as pressure increases with depth, isn't it? As the pressure increases with depth, then CP will lie, center of pressure will lie below the centroid of the plane surface. The center of pressure, because the pressure is increasing with depth, when more is the pressure at the bottom, less is the pressure at the top. So we can say that location of center of pressure will also be towards more pressure. It will be towards more pressure. So this is the location of CP, let us say. This is the location of CP. So the hydrostatic force must be shown here. The hydrostatic force must be shown at the CP, and the depth of CP from the free surface is known as HCP. The depth of central pressure from the free surface is known as HCP, and the depth of centroid of the plane surface is known as X bar, isn't it? So to find the value of, to find HCP, what we need to do, we need to equate moment about free surface. What we need to do is, we need to equate the moment about free surface. So if I ask you what is the moment of df about the free surface, the moment of df, or if I ask you what is the moment of f about the free surface, if I calculate moment of f about the free surface, what is moment? Moment is force into perpendicular distance. So f into HCP, that is the total moment. And what is the moment of df about the free surface? Df into x, yes or no? So it will be df into x, and if you integrate it, then you will get total moment. Total moment is equal to integration of dm. And what was df? So f, that is f into HCP, will be equal to rho into g into x into dA. So integration of x into dA into x, it will be x square into dA, and x square into dA, integration of x square dA is I naught. It is called as I naught. So I naught is nothing but area integration of x square into dA, that is I naught. I naught is area moment of inertia of plane surface, area moment of inertia of the plane surface. This is important. Equate the moment about the free surface. Area moment of inertia of the plane surface about free surface. About free surface. So our expression will become F into HCP is equal to rho into G into I naught. Isn't it? And this I naught can be replaced by IG plus A into x bar square. That is parallel axis theorem. You must have studied parallel axis theorem. G is here. So IG is the area moment of inertia. This is IG. And this is x bar. X bar. So I naught will be equal to IG plus A into x bar square. So F is equal to, if we put the value of F, rho into G into A into x bar into HCP will be equal to rho into G into IG plus area into x bar square. If you further simplify this, rho is getting cancelled out with this rho, G is getting cancelled out with this G, and HCP is equal to, if you divide by x bar, so IG by AX bar plus AX bar square by AX bar. So if you simplify this, area getting cancelled out, x bar x getting cancelled out with this x bar. So HCP is equal to x bar plus IG by AX bar. This is the expression for depth of CP from the free surface of the liquid. That is depth of central pressure from free surface of liquid. Depth of central pressure from the free surface of the liquid. These are the two formula you need to remember. What is the IG here? X bar you all know. X bar is the depth of the centroid of the plane surface from the free surface of the liquid. Area you know, area of the plane surface in contact with the fluid. Now only unknown is IG. IG is the area moment of inertia of the plane surface about its centroidal axis. What is the centroidal axis? Passing through G. The axis passing through G, and which is parallel to its base. This is IG. So for standard figures, if it is a rectangle, If it is the rectangle of dimension L by B like this, if it is L by B, then what we will do? We will find out the location of G, and this will be IG. What is IG? IG will be equal to L B cube by 12. If the rectangle is like this, if it is kept like this is B, vertical is L, then base will be B here, this is G. IG in that case will be equal to BL cube by 12. If it is a square, A by A, if it is a square, then IG will be like this. IG will be equal to, L is equal to A, B is equal to A. So A to the power 4 by 12. For rectangular plane surface, IG will be calculated like this. If it is a triangular plane surface, if it is a triangle like this is H, this is B, then for a triangle, this is, let us say, G, IG will be equal to BH cube by 36. Or if the triangle is like this is B and height is H, this is, let us say, G, IG will be equal to BH cube by 36. As long as base is B and height is H, even if the triangle is like this, then also it will be BH cube by 36. If it is a circle, these are the standard figures. If a circle of diameter D, then IG will be equal to pi by 64 D to the power 4. These are some of the standard figures for which IG you should always know. That is all about the vertical plane surface. Are you getting it? That is about the vertical plane surface. These are the formula for IG. If you know IG, area moment of inertia, if you know X bar, if you know area, then you can easily find out the depth of center of pressure from the free surface of the liquid. So for a vertical plane surface, what all the formula we have discussed, F is equal to average pressure into area, or we can simply use the formula rho G A X bar, where average pressure is pressure at G, at the location of G, that is rho G X bar, and this is the formula for F, and HCP, the point of application, is given by X bar plus IG by A X bar. It is greater, HCP is greater than X bar, isn't it? HCP will be greater than X bar. These are the formula you should, this is CP. The force must be shown here, and this is HCP. I hope this is clear. Is this all clear? Anybody is having any doubt? Anyone having anything to ask? Please do let me know. कोई भी confusion है? So HCP is always greater than X bar. But is there any possibility that CP and G almost coincide with each other? Is there any possibility that CP, center of pressure, and centroid of the plane surface almost coincide in case of vertical plane surface? Yes, there is a situation. The center of pressure will almost coincide. The center of pressure will almost coincide with the centroid of the vertical plane surface if its depth of immersion is very, very large. So what does that mean? HCP is almost become equal to X bar if X bar is very large. If the value of X bar is very large, then HCP will almost be coinciding with X bar. I hope this is all clear. Similarly, for an inclined and horizontal, we can develop the formula. For center of pressure, what we need to do is we need to equate the moment about the free surface, and for hydrostatic force, we need to do the integration of dF. That is how we can calculate the total hydrostatic force as well as the point of application. So I am just giving you all the orientation, position or orientation. The first orientation is when the plane surface is having an inclined orientation with an angle theta. So hydrostatic force is rho g a x bar, or we can call it as average pressure into area. If it is vertical, what is theta? Theta is here, theta is angle of inclined surface with horizontal. It is the angle of inclined surface with the horizontal. With the horizontal or with the free surface. Angle of inclined surface with the free surface or with the horizontal. For vertical plane surface, what will be the value of angle theta? If it is the vertical plane surface, theta is equal to 90 degree. HCP is given by equating the moment about the free surface. HCP is given by x bar plus Ig by Ax bar sine square theta. Here sine square theta will appear. For vertical plane surface, it is again average pressure into area. So the formula will remain same. And HCP, because theta is equal to 90 degrees, sine 90 is equal to 1. So it will become 1. So x bar plus Ig by Ax bar, that is what we have already discussed. The third orientation is, the orientation number 3 is horizontal. For horizontal, theta is equal to 0 degree. The formula for hydrostatic force is again average pressure into area. HCP will be x bar y because sine 0 is equal to 0. The second term will be equal to 0. That is why the location, the depth of CP from the free surface will be same as x bar for horizontal plane surface. What is average pressure? Where the average pressure is always the pressure which is developed at centroid, that is equal to rho into g into x bar. These are the formula for all the orientation of the plane surface. These are all the formula for all the orientation. Now the concept will become clear only when we discuss some problems related to these formula. Formula anybody can memorize. Formula तो एक छोटा बच्चा भी याद कर सकता है, but the real test is to apply these formula in solving the numericals. So get yourself ready with pen and notebook and calculator if required, right? But before that, there is important information announcement. On 3rd of April at 7:30 p.m. there will be an interactive workshop that is completely free, taken by Richa ma'am. She will discuss how to crack GATE 2025, how to prepare for clearing the GATE 2025 with the best possible rank. What you need to do is you can just register yourself through the link which is already there in the description box and share this information to others also. And if you are interested to be part of our paid course, then there is a golden opportunity to get up to 90% of scholarship in our paid course. And how to avail that scholarship? By appearing in the scholarship test for GATE exam, which is going to be conducted on 14th of April between 9 a.m. to 9 p.m. The syllabus for the test will be general aptitude as well as the mathematics, which is common for all the branches. You again have to register yourself before appearing for the scholarship test, and the link is already there in the description box. So the important point here is all the important links are already mentioned in the description box, and you can just go through the description to get the important links so that you can avail these freebies or free sessions for your own benefit. All right. So let us discuss the question. Everybody, please give it a try. There is a question on the screen. I want you guys to give it a thought and give it a try. The question says, the depth of center of pressure. There is a difference between depth of centroid of the plane surface and the depth of center of pressure. For a rectangular lamina immersed vertically in water up to a height h, there is a rectangular lamina which is immersed up to a height h in the liquid, like this. Let me call this to be B. What is the depth of center of pressure? Definitely it will not be h by 2. H by 2 will be x bar. Are you getting it? X bar will be h by 2. The depth of centroid will be, the depth of centroid will be h by 2. But the question is not about the depth of centroid. The question is about the depth of center of pressure. So we need to find out HCP. HCP. Formula is HCP is equal to x bar plus Ig by Ax bar. Why this formula? Because it is kept vertically. X bar is h by 2 plus what is Ig? Ig is the area moment of inertia about the centroidal axis parallel to the base. Ig will be equal to B into h cube by 12. Yes or no? So B into h cube by 12 into area of the plane surface in contact with the fluid, that is B into h into x bar, that is h by 2. What will be the answer? Can you solve it? Can you solve it? Which of the following is the correct answer? B, width will get cancelled out here. 1h, 2h, these 2h will get cancelled out here. So it will be h by 2 plus 2 and this becomes 6. ये हो जाएगा 6 plus h by 6 is equal to HCP. Solve कर सकते हैं. 6, 3h plus h, 4h by 6 or HCP is equal to 2h by 3 will be the final answer. Yes or no? Very nice Kumar. Good. Well done. 2h by 3. बहुत सारे स्टूडेंट यहां पे मिस्टेक करते हैं. As soon as they see the depth of the center of pressure, they say h by 2. H by 2 will not be the depth of center of pressure. The h by 2 is the depth of centroid of the plane surface. There is a huge difference between the center of pressure and center of gravity. The point of application of this hydrostatic force will be center of pressure, not the center of gravity. Now the next one, the next question, I want everyone to give it a try. Question number 2. Every one of you, please give it a try. It is an equilateral triangle. It is not shown like equilateral triangle. This is, let us say, A. This is also A. This is also A. Equilateral triangle. Triangular plate. It is a triangular plate. The figure is already shown. It is not looking like equilateral triangle though, but yes, it is equilateral triangle. Forget about the figure. Is immersed in water as shown in the figure. The center of pressure, again the location of center of pressure below the water surface is at a depth of, again we need to calculate HCP, again we need to use the formula this. Yes, let me know who will be the one giving me the correct answer. If I ask you what is the value of x bar, if I ask you what is the value of x bar, if h is the height of the triangle, h is the height of the triangle, isn't it h by 3? X bar will be the depth of centroid from the free surface, h by 3. But the question is about depth of CP. The question is about HCP. And what is Ig? This is Ig. So if we do the calculation with the correct information, x bar will be h by 3, Ig will be equal to A into h cube by 36. What is the area of the plane surface? This is half into base into height into x bar, h by 3. This will give you the answer. This will give you the answer. Everybody, please give it a try. A getting cancelled out. 1h, 2h getting cancelled out with this h cube. 6, it will become 6. So it will be h by 3 plus h by 6. That is 2h plus h by 6, or that is 3h by 6, or we can say h by 2 will be the depth of CP. D will be the correct answer. Well done, Kumar. Well done. Bye, Palli. Good, good, good. What about others? Are you able to understand? Are you able to do the calculation correctly or not? One more question. Very, very beautiful question. The one who will get me the right answer without my help means you are very much comfortable with the concept. There is a vertical gate of 6 meter by 6 meter. That means a square. The shape of the gate is a square. Holds water on one side with the free surface at its top. The free surface is coinciding with the top edge. The moment about the bottom edge of the gate, if we calculate the moment, force into perpendicular distance, the moment about the bottom edge of the gate of the water force will be about the bottom. We need to calculate the moment about the bottom in terms of gamma. Gamma is the specific weight of water. What is gamma? That is rho into g. So if there is a square gate, the shape is like this. This is 6 meter, this is 6 meter, and the free surface is coinciding with the top edge. This is how it is. So if I ask you the location of G, you will say x bar will be equal to 6 by 2, that is 3. Yes or no? So if I ask you what is the formula for force, rho of the fluid into G into A into x bar. This is the formula. Rho is 10 to the power 3, or rho into G. Rho of water into G is gamma for water, because the options are in terms of gamma. Gamma for water. What will be the area? 6 into 6. Area of the plane surface is 6 into 6 into x bar. X bar will be 3. So the force will be equal to 6 into 6 into 3 into gamma W. Yes or no? That will be the force. Now if we want to calculate the moment, listen very carefully. The force will be 6 into 6 into 3 into gamma. But if we want to calculate the moment, then the point of application will be very much important, because the force always acts at center of pressure. The force always acts at center of pressure, not the center of gravity. So find out the value of HCP. We need to calculate HCP from the free surface. So HCP is equal to x bar plus Ig by A x bar. X bar is equal to 3. What is Ig? Ig will be this. BH cube by 12. This is 6 meter. This is 6 meter. So 6 into 6 cube by 12 into area, that is 6 into 6 into x bar 3. This will give you Ig. So if you further simplify, what is the value of HCP? What is the value of HCP? 6 is getting cancelled out with the 6. 6 getting cancelled out with this 6 cube. 3 will get cancelled out with this 2. This is 6. So it will be 6 by 6. So it will be HCP, isn't it 4? Yes or no? The value of HCP, isn't it 4 meter? HCP will be 4 meter. If you are able to find out this depth of CP correctly, then this is the bottom. If we ask the moment about the bottom, then this will be the perpendicular distance. This will be the perpendicular distance. So if this is 4, then totally 6, isn't it 2 meter? So moment about the bottom will be the force into 2 meter. Yes or no? Moment about the bottom. Isn't it 4 into 2? F into 2. So F is equal to 6 into 6 into 3 into gamma. How much is that? It was 108 gamma W Newton. This was force. So we can say it will be 108 gamma W into 2. That is Newton meter. So it will be 216 gamma W is the moment about the bottom. Yes or no? Are you getting 216? Are you getting 216 gamma W? 216 gamma W will be the moment about the bottom. If the question is about moment about the top, then same force will be multiplied with 4 meter about the top. If the question is to find out the moment about the top, then the same will be multiplied with 4. If the question is about the moment about G, then this distance would have been taken into consideration. F into, it will be 4 minus 3, that is 1. F into 1. Yes or no? So that is how this is important. The perpendicular distance is important from the point of application. Perpendicular distance should be measured from the point of application of this hydrostatic force. Do you guys understand? Yes or no? Give me yes. D will be the correct answer, not C, not anything else. I hope this is clear to everyone. If anybody is having any doubt, anything to ask, you are most welcome. Bataiye. So this is all about the plane surface. Now we will move to the curved surface. Clear hai kya? Is this all clear to everyone? Now for clearing the gate examination with the flying colors, you require two things. One is your hard work plus the right guidance. Hard work and right guidance. So you can see those who are part of Byjus exam prep, they have done wonders in GATE 2024 because we have provided them a platform, organized, systematic, result-oriented platform, and they were ready to do the hard work with full dedication. So they could have managed single digit or double digit ranks in the GATE 2024. If you are sincerely preparing for GATE 2025, you can also join our vision batch for 2025 and 2026. What we offer you is the live classes, recorded lectures, study materials, and quizzes every day, daily based quizzes for improvement your understanding, and timely mock tests. If you avail these facilities in a systematic and organized manner, then nobody can stop you from getting the success. If you are interested to be part of our paid course, then you can connect with our counselor, or you just fill the counseling form. Our counselor will guide you throughout for the paid course or for your efficient preparation and your career opportunities. The link is again in the description box. Now let us move to the curved surface. Earlier we were talking about a plane surface. Now if the surface is not plane, if it is curved like this, you can only see a arc. You can only see the arc. You may not be able to see the width of the surface which is into the plane like this. Are you getting it? This is how it is kept. This is the top and this is the bottom. So again at a depth x from the free surface, what will be the pressure? At a depth x from the free surface, the pressure is given by rho into g into x, and df will be equal to p into dA, that is equal to rho f into g into x into dA. That is what we have done. But now if you observe, because the surface is curved, so the force is always normal and compressive. the direction of force is horizontal at the top, the direction of hydrostatic force will be vertical at the bottom. The direction of hydrostatic force will be at some angle here, the direction of force will be at some angle here. So because of curved nature, the direction of force is continuously changing along with the magnitude, isn't it? So we can say in curved surface, direction of force also changes along with the magnitude, isn't it? So what we need to do is we cannot do the integration. So integration is impossible because the direction is also changing. So we cannot do the integration. So what we can do is resolve into horizontal and vertical components. Resolve into horizontal and vertical components. At this location, this is df. And theta is the angle with the horizontal. Let us say this is theta. So df will be resolved into dfh and dfv. The total hydrostatic force will be resolved into horizontal and vertical components. If theta is the angle with the horizontal, this theta. So df is also making an angle theta with the vertical. So dfh is df sin theta and dfv is equal to df cos theta. So we need to resolve into horizontal and vertical components. That is how the analysis will be done for a curved surface. I hope this is clear. Is this clear to everyone? We cannot do the integration. Earlier, in case of plane surface, we could have done the integration. Why? Because only the direction of force changes. Only the magnitude changes, direction remains same. But here, along with the magnitude, direction is also changing. That is why the integration will not help. It will be resolving the force into two components. So if we calculate, so dfh is given by df sin theta, or we can say rho into g into x into dA sin theta. What is dA sin theta? dA sin theta is the vertical projection of dA. It will be the vertical projection of dA. So if we integrate, so fh will be equal to integration of dfh, that will be equal to rho f into g into total vertical projection of the curved surface into x bar. It is similar to the previous expression. Here AVT is vertical projection area of curve. It will be vertical projection area of curved surface, right? And x bar is again depth of centroid. It will be the depth of centroid of vertical projection area, of vertical projection from free surface. So what we need to do is, if there is a curved surface, we will always take the vertical projection of the curve. We will always take the vertical projection of the curve, and the vertical projection of the curve can be treated as a vertical plane surface. The vertical projection of the curve can be treated as a vertical plane surface, and apply all the formula rho g ax bar for hydrostatic force, and for HCP it will be x bar plus Ig by Ax bar. A and Ig will be, or x bar will be for vertical projection. Everything will be for the vertical projection. That is how we can calculate. This is the vertical projection area. The horizontal component. So the conclusion here is the horizontal component FH is equal to hydrostatic force on its vertical projection area, and the line of action, look, the line of action of this FH, this is CP for the vertical projection. So the line of action of this FH will pass through CP for the vertical projection. This is how FH will be applied, and we can easily find out this distance, that is HCP, from the free surface. This is HCP. The line of action of this FH will pass through CP for the vertical projection. Area is for the vertical projection, X bar is for the vertical projection, and IG is also for the vertical projection. Everything will be taken for the vertical projection. So take the vertical projection of the curve and forget about the curved surface. You can get the horizontal component of hydrostatic force. Good to go? Clear? And how to calculate the vertical force? DFV is given by dF into cos theta, or we can write it as rho into G into X into dA cos theta. X into dA cos theta is what? dA cos theta will be horizontal projection. dA cos theta will be a horizontal projection of dA. dA cos theta is horizontal projection of dA, and multiplied by X will be volume. This multiplied by X. This is X. X into dA cos theta will be this volume dV. X into dA cos theta will be dV. And if we integrate from A to B, then it will be the total volume. So FV will be equal to rho into G into integration of dV from A to B, and this will be the total volume of the fluid. It is total volume contained by curved surface. Curved surface. The total volume contained by the curved surface is integration of dV multiplied by rho and G. Volume multiplied by rho is mass into G. So Fv will be equal to, it is the weight of the fluid. It is the weight of the fluid because density of the fluid is taken into consideration, contained by curved surface. Contained by curved surface. Up to free surface of the liquid. Up to the free surface. Fv is the weight of the fluid contained by the curved surface up to the free surface. Why there is a different approach for FH? Because we can, there, according to Pascal law, the pressure remains constant in a horizontal plane. The pressure remains constant in a horizontal plane. That is why we can easily take the vertical projection of the curve to calculate FH. But according to hydrostatic law, pressure increases linearly with depth. Pressure is different at different depth. That is why we cannot take the horizontal projection of entire curve. What we need to do is, we need to calculate X into dA cos theta here only. We need to calculate X into dA cos theta. We need to add all X into dA cos theta to make the integration of dV. Are you getting it? That is why it is the weight of the fluid which is contained by the curved surface up to free surface. That is how we can calculate Fv. So for FH, take the vertical projection. For Fv, calculate the weight of the fluid which is contained by the curve up to free surface. Weight of the fluid, this weight of the fluid. Now vertical component is equal to the weight of the fluid which can be contained. So what we need to check, extend all the edges. How to calculate the fluid can be contained? Extend the edges of the curve normally up to free surface. If you extend the edges of the curve normally up to free surface, then you will get the total weight of the fluid which can be contained by the curve up to free surface. That will give you Fv. And the line of action of this Fv, the direction will be decided by actual contact. If the liquid is in contact from the top, the direction will be downward like this. But the line of action of this Fv will pass through centroid of the corresponding weight. Centroid C of the corresponding weight. This is how Fv will be calculated, and Fh will pass through Cp for the vertical projection. This is how FH can be calculated. Are you getting it? This is how FH will be calculated. This is FH. I hope this is clear. And once you get FH and FE, then the resultant force is under root of FH square plus FE square, because horizontal component is perpendicular to vertical component. This is the total or resultant hydrostatic force. Total or resultant hydrostatic force on curved surface. And we can also find out this is resultant. This is FR. We can also find out this angle phi. Phi will be equal to tan inverse of FE by FH. What is phi? That is angle of this FR with the horizontal. Angle of FR with the horizontal. So this is how we can find out horizontal and vertical component. Look, if the liquid is on the other side, try to understand. What we need to do is we need to take the vertical projection for FH. No matter whether the fluid is on the left or the right hand side. This will be the horizontal projection. Take the horizontal projection and find out FH by calculating rho g a x bar for the vertical projection. And the line of action will be passing through CP for the vertical projection. But the only thing is the direction of FH will not be towards right now, because the actual contact is from the right. So the direction of FH will be like this. That is the only difference. FH will be equal to rho into G. Rho is the density of the liquid into area of the vertical projection. This is vertical projection. Into X bar. X bar is the depth of G from the free surface. This is X bar. This is FH. And HCP will be equal to X bar plus IG by A vertical X bar. This is HCP. HCP. Now, how to calculate the vertical force? For calculating the vertical force, extend the edges normally up to free surface. It does not matter whether the liquid is on the left or on the right hand side. Extend the edges of the curved surface up to the free surface like this, because it is about the weight of the fluid which can be contained. I hope you have understood that. Weight of the fluid which can be contained. Actually, whether it is containing any liquid or not, it does not matter. The width is into the plane of the board like this. So it is the weight of the liquid which can be contained by this curve. So this weight of this fluid will be the magnitude of Fp, and the direction will be not downward here, because the fluid is in contact from the bottom. So the direction will be upward. Fp will be in upward direction, and the line of action of this Fp will pass. The line of action of this Fp will pass through centroid of the corresponding weight. So this is how you can have FH and Fp, and the resultant will be something like this. The resultant of these two will be something like this. This is how the resultant will be, and the resultant will be, this is angle phi. This is the resultant Fr. I hope you are clear with this. So for horizontal component, take the vertical projection of the curve, and for vertical component, extend the edges of the curve normally up to free surface to get the weight of the fluid which can be contained by it. So this is how you can find out horizontal and vertical component and the total hydrostatic force. Let us discuss one question before we end our session. One end, the question says, one end of a two-dimensional water tank has the shape of a quadrant of a circle. It means 1/4 of a circle. Quadrant of a circle of radius 2 meters. This is, let us say, the circle. And quadrant of a circle means This is the quadrant of a circle. This is our surface. One end of a two-dimensional tank, it is two-dimensional. Width is not given. Width we can take as W, let us say, or width we can take B. Width is into the plane of the board, let us say B. When the tank is full, the vertical component, when the tank is full up to this point, when the tank is full like this, like this is how the tank is full. This is the tank. This is the free surface. When the tank is the full, the vertical component of the force per unit length, it means you can call it as the length. Length is unity, which is into the plane of the board. Length is unity on the curved surface. So for vertical force, I have already told you what we need to do is extend the edges normally up to free surface. So the weight of this liquid will be Fp and it will act in downward direction. So Fp will be equal to rho of water, because it is a water tank, into volume, rho into G into volume. What is this volume? Isn't it pi r square L? What is r? Radius is 2 meter. Pi r square into L by 4. Yes or no? It is 1/4 of a cylinder. So if you put the value, that will be in Newton, and 1 kgf is equal to G Newton. So if you want to convert into kgf, the units are in kgf. So density of water is 10 to the power 3. G Newton is equal to 1 kgf. So into pi r square into L by 4. So this will get cancelled out. So it is 1000 pi kgf will be Fp. Yes or no? 1000 pi kgf will be the vertical force. 1000 pi kgf will be the vertical force. If I ask you what will be the horizontal force, for horizontal force, extend the edges for horizontal force, take the vertical projection. If you will take the vertical projection of this, then the vertical projection will be a rectangle of dimension 2 meter by 1 meter. So Fh will be equal to rho G. If we calculate Fh, rho of water into G into area of the vertical projection, 2 into 1 into x bar. What is the value of x bar? The depth of G, that is 1. That will be in Newton. In kgf, it is 10 to the power 3 into 2, that is 2000 kgf. Isn't it 2000 kgf? It will be 2000 kgf. Rho G A x bar. And the line of action of this Fh will pass, the line of action of this Fh will pass through Cp for the vertical projection. And how to find out the Cp? HCP will be equal to x bar plus Ig by x bar. It will be 2 into 2 by 3. 4 by 3 meter. So this is how you can calculate Fh and Fp for this quadrant of a circle easily. I hope this is clear. So this is your assignment question. Please try to solve this question at home and bring me the answer in next class, or you can share your answer through the comment section. This is an inclined surface. For an inclined surface. All right. So tomorrow we will be meeting for one last time at 6 p.m. where we will talk about the concept of buoyancy and the Archimedes principle related to the buoyancy. All right. And not only on YouTube, we are running free classes on the Byjus exam prep app also. The series name is Ground Zero series for all the branches for GATE 2025 aspirants. And for attending the sessions on our app, what you need to do is you need to download the Byjus exam prep app from the Google Play Store, or there is a link in the description box. So just download it, and not only the concept classes, but there are quizzes, there are practice sessions which you can attend, which you can watch for getting maximum benefit out of our free classes on the Byjus app also. All right. So this is my link to join me on the Telegram, or you can connect with me on the mail ID. So guys, that is all from my side. I hope you enjoyed the concept of hydrostatic forces. You learned the concept of the hydrostatic force in the simplest possible manner. If you have anything to ask, you can just do let me know through the comment section, or you can just let me know through the Telegram channel as well. So that is all from my side for the day. See you tomorrow at 6. Till then, enjoy, take care, have a good day and a great career ahead. Thank you once again. Jai Hind.